As most of you know, cryptocurrency mining has been quite popular over the past several years. And following that trend, my brother has put together his own mining computer to create his own cryptocurrencies. After Ethereum switched to proof of stake, however, the older mining methods no longer work, which is what my brother was doing. So, he had to switch to other coins like Ergo and Flux to continue mining. The problem now is that these coins earn less than Ethereum used to. And with the desire to add more graphics cards, power usage is now an issue we have to keep in mind. So the question is, whether his crypto rig is both within a reasonable limit, and whether the rig is currently profitable. Let's find out. The first thing we need to do is determine what our power limits are. To help us out, my grandfather came over. He's an electrician, so he knows a great deal about this kind of thing. And he also brought an ammeter to help us out. Anyways, by going to the breaker box, we can find that the limit is 15 amps. We can also measure that the voltage coming in is 120 volts AC. The first thing to do is to determine whether the mining rig is currently drawing more than the 15 amps of current that is required to flip the breaker. By putting the current clamp around the wire, we read 8 amps of current flowing through it. By using the power equation, we get a power draw of 960 volts, so it is well within the limits, so there aren't any worries there. Funnily enough, his rig is basically the only thing in the house drawing any current. The main breaker is not much higher than 8 amps, although the dryer does use a few amps when it is turned on too. Anyways, the next step is to determine whether his mining rig is currently generating a profit. The way we can do that is by determining electricity costs as compared to the amount of crypto his mining currently brings in. By looking at his mining control panel, we can see that he currently earns 76 cents per day. But that's just earnings. Let's also take a look at the costs behind the rig. Where we live, the cost of electricity is about 7 cents per kilowatt hour. That means if he uses 1,000 watts for an hour straight, he'll be charged 7 cents. So let's see how much power he's actually using. The easiest way to find that out is by just going to the mining control panel. Here, it shows that he's using 530 watts distributed across the 4 graphics cards. That means it costs 3.7 cents per hour to run. Converting his daily profits to hourly profits, we get 3.2 cents per hour, which is less than the electricity that it generates. So it runs at a deficit of half a cent per hour, or 12 cents per day. There's just one problem though. The power calculated from the breaker is different than the power shown here. So are the calculations correct? Well, let me explain. When it comes to DC voltages, it is rather simple to calculate the power usage. Just multiply the current by the voltage and you'll have your answer. This is likely how the control panel is measuring the power usage of the system. And this measurement is correct, but it isn't what the AC measurement is showing. It comes down to the behavior of AC circuits and voltages, and the difference between true and apparent power. In general, DC circuits have similar true and apparent powers, but AC is different. You may have heard of the term phase shift. Let's take a look at a sine wave, which is what AC typically uses. We can, for example, represent the voltage waveform in green by using the equation sine of t. We will also represent the current flowing through it with red in the equation sine of t as well. So far, the true and apparent powers are the same since the current and voltage align, just like they would in a true DC circuit. But the problem comes with a phase shift. Let's modify the current waveform and place it out of phase by 90 degrees. Now we can see that the current and voltages both have the same RMS value, but they do not align. Now, the phase shift itself does not cause the power difference. Rather, it is a good way of visually showing what is happening. These phase shifts are caused by the reactive components, which are inductors and capacitors. Resistors do not cause phase shifts since they are resistive, not reactive. We can simulate this idea with a circuit on the breadboard. Let's grab 2 oscilloscope probes to visualize it. The yellow one will be with the voltage, and the purple will be the current. With only a resistor in the way, the current and voltage curves are completely aligned, no reactance here. With either a capacitor or an inductor, however, the current will be 90 degrees out of phase, but in opposite directions of course. However, a combination of capacitors and inductors will give us different results, in between 0 and 90 degrees depending on the combination. And a perfect combination of the two will align the current and voltage together, giving us resonance. So, in order to determine the true power by using the apparent power, we can use what we call a power factor. The power factor is simply the ratio between the true power and the apparent power. The power factor is also equal to the cosine of the phase angle, which is also equal to the resistance divided by the impedance. Since the apparent power isn't consumed like the true power is denoted with the units of volt amps, as opposed to just watts by themselves. But where is all this impedance coming from anyway? Well, remember that the real world is not perfect. So inductance comes from the wire itself. Capacitance can come from the close proximity of the wires. Not to mention that the actual power supply itself, which contains multiple capacitors and inductors in order to create a switch mode power supply. This is a big consideration since the apparent power is the thing that all the components have to be rated for. The breakers will break at their specified currents. The same can be said with the wires, but despite all this, the electric bill is still the same. The reactive power is not actually used since the inductors and capacitors will return their power when they are done. So all that explains the difference between the powers calculated, and the actual cost of the mining rig doesn't actually change, so nothing has to be worried about there. So, we have arrived at a verdict. His rig is unfortunately running at a very, very slight deficit. Although I know he's waiting for the price to increase, then it will be a net profit. On the other hand, his rig is completely within the operating limits of the circuitry of a house. So it's good news, so he can keep it running if he wants it to. Anyways, I hope you learned something new from this video and now understand how much your current electricity usage costs. If you enjoyed, please consider subscribing so that you can see my other videos. Have a good one.